Good morning to you from us. Here we are with our talk with this overly long and complicated title. I'll start to explain what the DBpedia is and what we're doing in the DBpedia. We are extracting knowledge from Wikipedia. So how do you extract knowledge from Wikipedia? We are mapping Wikipedia data, that is the fixed structural information that can be identified, like templates for geodata, info boxes, the titles, abstract, and so on. We are mapping all this to ontology, classes, and properties to get linked data out of it. Why do we do this? We want to turn the documents that are making up Wikipedia into data that can be used more granularly and can be queried more granularly than documents can be. And the result is a very large multilingual knowledge base that provides a common structure over the different language versions of the Wikipedias. The organization of, there's a slide missing, I think. Okay. The organization of the DBpedia is, we are part into chapters. It's 14 language chapters that are maintaining their respective versions of the DBpedia, and so they are able to maintain their specific language, provide correct mappings for their specific language, and can provide for the quality and coverage beyond the language borders. All these chapters are supported by the newly founded DBpedia Association, which is trying to opening the research project that DBpedia still is to industrial use cases and industrial sponsors to make it possible to go on with this, from our point of view, very important project into linked data. Here it is. You can see DBpedia in the center of the LLD cloud. It's a very important source of world knowledge, so it's a very nice thing to link from all kinds of different data sets. So a little more explanation. It's not very orderly. Well, we see we have Wikipedia pages in different language versions, and these are mapped by the different chapters according to their language into the versions language.dbpedia.org. So they are relatively independent. That's reflected in our talk today. So I'm from the German chapter, Marco from the Italian, Mariano from the Spanish chapter. We've never met before, but that's how it goes. The use cases we can present for the multilingual knowledge base. The first one is an industrial use case we are calling the abbreviation base or abbrev base. It's based on a ULI use case. This is a Unicode Localization Internationalization Technical Committee. And what are we doing? We are compiling directly from DBpedia data a multilingual knowledge base of abbreviations. Abbreviations defined as strings that could be confused with sentence boundaries or other text segmentation or strings important for text segmentation. While doing this, ULI has the specific use case where they are using abbreviations as exceptions in their rule-based text segmentation tools. And they just need more, and for most importantly, they need the abbreviations multilingual. And with the help of the DBpedia, this is relatively easy to do, because the only thing we have to do is extract words that somehow look like sentence boundaries defined by the tools that ULI already has developed. And we compile them together per language and model them with the Lemon model as dictionaries. So in this case,
very good.
Okay, thank you, Martin, for the brilliant introduction. Let me spend just a few words about myself first. I'm the Italian DBpedia chapter representative, and I work as a research assistant at the Web of Data unit in Fondazione Bruno Kessler Research Center, located in Trento, Italy. And, I think this is one of the shortest talks I've ever made. I will try to cover in 5 minutes, in like elevator pitch style, the main achievements of the Italian DBpedia chapter since its birth in 2012. So first in line, here is an industrial use case that has been carried out with Spazio Dati, an Italian startup located in Trento as well, for which I collaborate as a data scientist. Here we leverage DBpedia as a data source to build exhaustive gazetteers of real-world entities. So what is a gazetteer? We can define it as a linguistic resource, basically, which is both language and domain specific. So given, for instance, I don't know, the music domain, we want to provide the best coverage in terms of music-related entities, such as musical artists, as albums or songs, and so forth. Those gazetteers are building blocks of a natural language understanding system, which is able to classify a user query in a natural language, like play the Beatles, into the correct domain, the music domain, and also identifies the entities that the entity then needs to be played in some device. For here, the Beatles, for example. And this is made possible through one of the simplest query to the DBpedia knowledge base. All we have to do is just to ask DBpedia for music typed entities. So we just ask, give me all the musical artists in the Italian DBpedia, and we get the full list. This approach can be applied to all the other DBpedia chapters and is thus fully multilingual. Next comes a brief overview on the Italian DBpedia stakeholders, usually coming from open data and open knowledge communities. So first, the Open Coesione portal is a major example of open government in Italy that is made for transparency purposes. It exposes data about public projects that are funded by national investments, and it contains entities like typically companies or locations. And here DBpedia is useful for two aspects: enrichment and interlinking. The entities like locations and companies can be automatically enriched with encyclopedic information coming from Wikipedia, from the Italian Wikipedia. And interlinking improves the browsing capabilities, since it enables some kind of semantic relation discovery between those entities. The digital catalog of the National Library of Florence is adopting a similar approach with respect to books or writers and library-related entities. And last but not least, data-driven journalism is experiencing a steady growth. Journalists query the DBpedia knowledge base to pull slices of data that are relevant to their needs. And for example, in order to tell a story or to build an infographics like this that is worth 1,000 words, or for fact-checking, which is quite a trendy topic. Let's move now to a completely different topic. This is an event that has just successfully ended, namely the first Italian DBpedia mapping sprint. So you may wonder why I put students learn how to translate the culture. Well, because they were asked to map the Italian data coming from the Wikipedia templates into the DBpedia ontology. The former data is language and culture specific, while the DBpedia ontology aims at representing the whole world of all Wikipedias in all language. Hence, the ontology serves as some kind of multilingual glue and homogenizes the data coming from the different chapters and improves the data quality in general. And we did this under the form of a hackathon in a high school in the Trentino region with 5 classes and with a best prize for the best performance. All right, so it's time now for Mariano that will shed some light on the Spanish side.
Okay, thank you, Marco. I have 4 minutes to convince you about having your own DBpedia chapter. Indeed, as you see, this is not only a national effort, it's made of linguistic groups, and we have, in the case of the Spanish chapter, many countries under this group. As you see here, we have lots of languages, and we have only 14 chapters. So, although the Spanish chapter is in the top 4 group, I want to encourage you to have your own DBpedia chapter. And if you make, as Marco said, a group, you make a group of students or people well knowledge with a good knowledge of the culture of your language, you can make a hackathon as they did, and you can put your language with enough information to create a lot of RDF data, as we did in 2011. And I'm going to show you the case of the Spanish DBpedia. The Spanish DBpedia is not only a sparkling point, it's also a website that you can visit, and you have information there in English and in Spanish, and you can learn how to set up your system and how to get more information about queries, about anything you are interested in. It's a wiki, you can type and leave there all your knowledge. And in the case of the Spanish DBpedia, these are the location of the queries we got, basically from Spain and the South American countries, but as you see, from many other places in the world. And well, this is a ranking of the locations, and as you see, around 70% of the requests to the website were made from Spanish language browsers, but you have also English, 16%, and other non-English or non-Spanish languages. And concerning the queries, the Sparkle queries made to the Spanish DBpedia, these are the queries made in the year 2013, and you see that there are some special days that you get a lot of requests. I have to warn you about these IP monsters that can put your system down. So this is a detailed study of the kind of visitors you can have in your Spalkian point, and well, you can see here 3 kinds of visitors. Very demanding visitors here, but there are only a few. There are only 16. And you have more conservative with requests between 1,000 and 10 queries. And you have the long tail here with people that with less than 10 queries. So these are the noise generators. You have to take care with these guys that are probably asking for silly things. So the lessons I learned, and I want to warn you, is that you have to take care of the IP monsters, sorry. And the second lesson is to take care about noise generators. And that's all. Thank you so much.
Thank you very much.